Myself, Jayashree Shepalkar, welcomes you for the lecture series on computer graphics and visualization. Module number 1, lecture number 3. In the previous class, we have discussed about raster scan display systems, random scan display systems, and color CRT monitors. Today, we are going to discuss about three-dimensional viewing devices, stereoscopic and virtual reality systems, raster scan systems, video controller, and raster scan display processor, graphics workstation, and viewing systems. With this, you will be able to understand the overview of the computer graphics system. Three-dimensional viewing devices. The graphics monitor for the display of three-dimensional scenes have been devised using a technique that reflects a CRT image from a vibrating flexible mirror. So in three-dimensional viewing devices, there will be a CRT image, and from the vibrating flexible mirror, depending upon the varifocal mirror vibrates, it changes its focal length, and the vibrations are synchronized with the depending upon the display of the object on a CRT, so that each object is going to reflected from the mirror into a position corresponding to the distance of a focal length, and that focal length will be related with the specified view of the location, and this is going to allow us to walk around the object or a particular scene and view it on the different sides, so that we'll be able to get a different views from the different sides. In addition with the displaying of three-dimensional images, so it is often considered as displaying of two-dimensional cross-sectional images such as slices of objects and depending upon the different depths, and these such as medical images. So for example, ultrasonography as well as CAT scan devices and some applications such as geological applications, which is going to analyze the some topological and seismic data in terms of design and applications involving some solid objects, so that it will be very helpful for representing the three-dimensional simulations of the systems such as molecules and terrain, and these three-dimensional simulation will helps us to identify the different applications in any of the areas. And even the three-dimensional simulators can be used for training the pilots with some simulation tools, with the three-dimensional simulation tools. So actually the operation of the three-dimensional display system, this is can be done by using some vibrating mirror, and this is a focal length between the CRT and the flexible mirror. So this is a flexible mirror, always it will be a vibrating. So this flexible mirror is going to vibrate depending upon the distance, and the CRT to the vibrating mirror distance will be considered as a focal length. Depending upon this focal length, which is going to have a depth information between the geometric objects or the 3D image, and the distance between as well as the timing between the CRT to the vibrating mirror, so that thing will be controlled by the timing and the control system, so which is able to control the timing and the control systems depending upon the focal length of the CRT and the vibrating mirror. So this is going to change the focal length, which is going to map or match the depth of the points in a particular scene. So this is one example, a three-dimensional image. So depending upon the focal length of the user, consider suppose this as a user. So user is going to view the object, and this is what the projected 3D image behind of the vibrating flexible mirror. So which is going to have some depth information depending upon the focal length. So this is how the operation of three-dimensional display system with vibrating mirror. And to have that particular effect, so glasses are very necessary to view the three-dimensional effect with the depth information, because these glasses are going to help for viewing some stereoscopic scene in the three dimension. Stereoscopic scene in the three dimension means one eye Even our human eye is going to produce a one scene on the left side, and other eye, that is right eye, which is going to produce the other scene on the right side. If you combine both the scenes, there should not be an overlap between the two different scenes. That is what is called a stereoscopic scene in three-dimensional. Same thing, that particular depth information can also be exactly mapped with the object of the scene, with its height as well as the length, and the depth information of the three-dimensional object which cannot be overlapped with the other parts of the scene. That effect exactly can be monitored with the help of some stereoscopic glasses such as this. I think you might have noticed while viewing with three-dimensional movies, you will be given with some sun glasses. So that is what those are called as glasses for viewing the three-dimensional movies and all. I think you have noticed when watching with the three-dimensional movies and all. So this is how, if you don't wear these glasses, that depth information cannot be viewed exactly, because that depth information views will be monitored by the glasses of the stereoscopic scene in the 3D. Otherwise, you will have some blurred like a two-dimensional image itself, and the depth information can be viewed with the stereoscopic scene in the 3D. And this stereoscopic and the virtual reality system, another technique for representing a three-dimensional object is to display stereoscopic views. Stereoscopic views which will not produce the true three-dimensional image, but which is going to provide some three-dimensional effect by presenting a different views, such as each eye is going to produce a different views. Left eye is going to produce a left scene of the view, and right eye is going to produce the right scene of the view, and each eye of the observer, so that the scenes do not appear to have a depth. To obtain that particular stereoscopic projection, we must obtain the two different views of a scene depending upon the viewing direction along with the position of the eye, such as left and right. And we can construct these two views as a computer generated scenes in the form of three-dimensional images with different viewing positions, and depending upon the stereoscopic camera pair. And this will be helpful to pair the particular photograph or object of a scene, and when we are going to simultaneously look at the particular left view with the left eye and the right view with the right eye, and the two images or the two different views of a scene is going to merge into a single image, so that we can have a scene with some particular depth. That is what is called a stereoscopic projection of a three-dimensional image. One way to produce stereoscopic effect on a raster system is to display each of the two views on alternate refresh cycles. And alternative refresh cycle can be viewed with the on the screen, and that will be done with the help of glasses. Just now we have discussed about that type of glasses we are going to use to view the screen in three-dimensional, because with each lens is the screen glasses length. The glasses lens will be designed such a way that which is going to rapidly alternating shutter, and that will be synchronized to block out one of the different views. So one such design that we have used, and which uses liquid crystal shutters and some of the infrared emitters that synchronizes the glasses, and with that which is going to able to have different views on the scene. And stereoscopic viewing is also very important, and this is dependent as a virtual reality systems. Virtual reality systems, when the users can step into a scene and he is going to interact with a particular environment, and he uses a optical system to generate some stereoscopic views of a scene, and that particular viewing input devices, as well as they are going to locate the and manipulated objects in the scene, and the sensing system is in the headset is going to keep the track of the viewer's position, such as front and the back of the objects, and when the user walks through the interaction with the display, which is able to create a environment such as virtual reality environment for the stereoscopic viewing. So this is what is called is stereoscopic viewing, and another method for creating a virtual environment for depending upon the stereoscopic scenes. Now let us move to the raster scan systems. The interactive raster graphics systems typically employ several processing units in addition to the central processing unit, which has a one display purpose special purpose processor. That is what is called is video controller. Sometimes it can also be called as display controller. And this display controller is used to control the operation of the display device. Here the frame buffer can be anywhere in the system memory, and the video controller is going to access the frame buffer to refresh the screen. And in addition with the video controller, some of the raster systems are also going to have the other processors as well as the co-processors to accelerate the implementation of the computer graphics. So this is what the architecture of a simple graphics system. Input devices will be connected to the system bus, and through the system bus it will pass the information to the CPU system memory. The frame buffer can also be kept in the system memory, or it can be a part of the different memory also. And now the main component required for the raster scan display is video controller. This is what is called a display controller, which is the main component required to display graphics onto the monitor. So this is what the architecture, simple raster graphics architecture with the video controller. And the video controller is a fixed area of the system memory. This is also called as system memory itself, but some fixed memory will be reserved for the frame buffer, and the video controller is given the direct access to the frame buffer memory. The frame buffer location on the corresponding screen positions are referred as Cartesian coordinates. The Cartesian coordinates will be normally represented in terms of x and y axis. So x and y axis, if you consider the top in the raster scan display system such as our monitors, the top left corner, this top left corner will be considered as a origin. So this will be considered as x axis, and this is considered as y axis. So in Cartesian coordinate system, this will be considered as 0, 0. As it step it onto the x axis value will be incremented by 1. Same thing will be in the form of y axis. So in an application program, we use the commands to display some points onto the monitor. So to do that, this is what the architecture of a raster system with what exactly the system memory consists of. In the previous one, simple one, we have just replaced with the system. Now it is been added with a frame buffer. So frame buffer is also a part of the system memory, but this frame buffer is only meant for storing the picture or storing the any of the image onto the monitor. It will be stored in the form of pixels. So the frame buffer is also consisting of the number of pixels depending upon the resolution of the screen. So depending upon the resolution of the monitor, which is also have the part of the memory which stores all the images in the form of pixels, and then the video controller is going to gain the picture stored from the system memory, that is a part of the system memory what is called is frame buffer. Through the frame buffer, video controller will display the image in terms of pixels onto the monitor. So this is what the architecture of raster system with a fixed portion of the system memory, and that is what is called a frame buffer. Within a graphics software package, to set up the coordinates and positions which are going to display on the relative to the origin of the Cartesian reference frame, and the coordinate origin will be referenced as the lower left corner of the screen display area by the software commands. And although we can typically set the origin at any convenient location for a particular application. So some of the graphics softwares are going to be considered this point, that is top left corner will be considered as origin, and in some of the graphics application this point, that is bottom left corner, will be considered as a origin. So this depends upon the application programs and the software commands whatever we are going to use. For example, if you are using TC to send the commands to display any image onto the screen. At that time, this point, that is top left corner, will be considered as the origin. Now in OpenGL, whatever we are going to use in our programming, the OpenGL concept. So in OpenGL, whatever the window we are going to create to display the output, so for that particular window, the lower left corner will be considered as a origin, and this selecting of the origin will depend upon the application programs whatever we are going to use. And even we can shift out the origin also depending upon the convenience of the application. So this is how the Cartesian reference frame, this is x-axis and this is a y-axis. If you consider as an OpenGL application program, so this is considered as origin, this is x-axis and this is a y-axis. And the reference frame with the origin, at this particular origin, is at the lower left of the screen corner. The screen surface is represented as the first quadrant. This is considered as first quadrant, and then if you extend the x-axis, this is considered as second quadrant. If you extend about the y-axis in the downwards, this is third quadrant and the fourth quadrant. Like that, the even screen surface can be considered in terms of four quadrants also. But normally, the screen with the Cartesian coordinate will be considered as our first quadrant itself, which consists of only the positive x values which is increasing from the left to right, and the positive y values which is increasing from the bottom to screen to the top. And the pixel positions are assigned with the integer x values ranging from 0 to x max, and y values from 0 to y max. 0 to y max. However, all the hardware is going to process such a screen refreshing as well as some of the software systems reference to the pixel positions from the top left corner of the screen. The basic refresh operations of the video controller are diagrammed, and some of the two registers are used to store the coordinate values, because it is going to have a two axis, one is x-axis and the y-axis. To store these two different values of the coordinate values for the screen pixels, we need two different registers. Initially the x register is set to 0 and the y register is set to the value of the top of the scan line, and depending upon the content of the frame buffer at the pixel position, which can be retrieved depending upon the intensity of the CRT beam, and then the x register will be incremented by 1, and the process is going to be repeated for the next pixel on the top of the scan line, and this procedure is going to continue for each pixel along with the top of the scan line, so which is going to have all the pixels within its screen area. After the last pixel on the top of the scan line has been processed, the x register is set to 0 and the y register is set to the value for the next scan line down from the top of the screen, so that the pixels along with this scan line are then processed in turn, and the procedure is repeated for successive scan lines. And after cycling through all the pixels along with the bottom scan line, the video controller is going to reset the registers for the first pixel position, and then it is going to start with the from top scan line and refresh process starts over. So this is how the x register and y register to store the x values and the y values, and the frame buffer is going to locate the screen pixel positions, and the to store that pixel position there will be a pixel register depending upon the intensity of the CRT beam. So whatever the intensity will be assigned, so that will be assigned by the pixel register, so that with that particular intensity the pixel with the coordinate x and y values will be uh, stored with the same intensity, and that thing will be considered as a memory address, and that thing will be stored in the frame buffer in terms of Cartesian coordinates. And whenever it gets refreshed, whenever it gets to the next scan line each and every time, so that thing will be controlled by the video controller, and that video controller is going to refresh the operations depending upon the uh, x and y value registers are going to increment as well as decrement within the screen positions depending upon the Cartesian coordinates. Now let us move to the raster scan display processor. This is one way to organize the components of a raster system, which is going to be separated with a display processor, sometimes called as some graphics controller. So this is also called as display coprocessor. So the purpose of a display processor is to free the CPU from the graphics cores. So whenever the CPU is busy for any of the other work, so this display coprocessor will helps us to free the CPU for the particular graphics cores. In addition to the system memory, there will be a separate display processor memory area can be provided. So another part of the memory which is present in the system memory itself, and only the part of the memory that will be helpful for freeing the CPU for the some graphics cores and all, the part of the memory will be provided, and that part of the memory will be only used for display processor, and that memory area is what is called as display coprocessor or display processor. Similar methods are used for scan converting the other objects in a picture definition. Some characters even can be defined with a rectangular pixel of grids. So here these are, each triangle is considered as 1 pixel. So this total how many pixels in the x direction? Total 8 pixels in the x value, x direction, and the 8 pixels in the y direction. So each and every pixel will be considered with the rectangular or else with the square shaped. And this is what the pixel grid shown with some pixel grids with a rectangular shape. If I want to display the character, okay, so for that each pixel will be highlighted with some intensity value. So for this is what the displaying of the character B. So character B is going to have the outline like in this way. So one curve and another curve, and this is what the line. So this will, according to the shape of the letter B, which is able to display the all the pixel will be highlighted with some intensity, so that the B letter is going to be displayed onto the screen. So this is what the character defined as a rectangular grid of the pixel positions. Now here you can notice the character is defined with the outline shape. So outline shape which is going to have not in the form of pixels, only the lines, line drawing. So this is what the vector scan we can see. Vector scan display. So the line will be drawn from this to this position, then the curve, outline curve, another curve, like that the character B is drawn. So this is the character defined as an outline shape. So this is a vector scan display, and this is a, or we can say random scan display, and this is a raster scan display, in which the characters are defined with the rectangular grids or pixels. And the array of the character grids can even vary from any of the pixels. Here we have taken the 8 by 8 size. So even if the character grid scan is going to vary with some of the array size with x pixels as well as the y pixels, and even it can have a more number of pixels with higher quality displays. And the character grid is displayed by superimposing the rectangular grid pattern into the frame buffer with some of the coordinate position. If I say this particular position, so x is on to the 4 values, and as well as y is on incremented up to 4. So this location is going to have the 4 by 4 location. The display processors are also designed to perform a number of additional operations, such as even the various line styles can be drawn, such as dotted lines as well as dashed lines, some solid lines. Even it can also help to display the some color areas by applying some transformations to the objects in the scene, and which will help the display processors to design some interactive input devices such as mouse. Now let us move to the graphics workstations and the some viewing systems. Most graphics monitors today, whatever we are using, these are going to operate on the raster scan displays. Remember this. Both the CRT and flat panel systems Whatever the CRT, if you consider, even nowadays nowhere we are using a CRT, but nowadays we are using flat panel systems very commonly in use. And these graphics workstations are going to range from general purpose computer to even multi monitor facilities, and even which is going to have some ultra large viewing screens. For personal computer, resolution is going to vary from 640 by 480, indicates that 640 pixels in x-axis, 480 pixels on y-axis. So this is what the standard resolution is required, and another which is going to increase the resolution from the 1380 by 1024. Even the resolution can be varied depending upon the size of the monitor, and the size of the monitor of the screen is going to measure in the form of inches. That thing will be measured from the top left corner to right bottom corner in this way. So that will be either in the form of 13 inches starting with very small area, screen area, and nowadays whatever we are using the monitors with 15 inches to 17 inches of monitor, and even it can have a large screen area over up to 31 inches, 43 inches, 53 inches, and so on. I think you might have noticed with your TV screens and all. Most general purpose systems now have a considerable color capabilities with some full color systems, and for a desktop workstation which is specially designed for graphics applications, and the screen resolution is going to vary, that what is we have discussed. For 18 inches or more, normally the screen resolution is going to take 1380 by 1034 to even 1600 by 1300. And for commercial workstation, it can also be obtained with variety of devices for some of the specific applications. If you consider about some high definition HD TVs and all, with the increase, the resolution is going to be increased with nearly equal to 3560, means 3560 pixels in x-axis and 3048 in y-axis. Normally these are called as high definition HD TVs and all, and these are normally used for medical imaging and air traffic simulations as well as CAD applications. And many high-end graphics workstations also include for large viewing screens, often with some specialized features. I think you might have noticed with the multi-panel display screens used for variety of the applications of wall-sized viewing areas. And these systems are designed for presenting some graphics displays at meeting, conferences, conventions, some trade shows, retail shows, museums, and passenger terminals. So they will be able to see the total display screen with a wall-sized viewing areas. And the multi-panel display can be used to show a large view of a single scene or several individual messages. Only one view with a single scene, or even which is able to display the several scene with a different windows. And each panel in the system display is going to have one section of the overall picture. So today we have learnt about three-dimensional viewing devices, stereoscopic and virtual reality systems, and what is the raster scan graphics architectures, and video controller and raster scan display processor with some graphics workstations and the viewing devices. So with this now I think you are able to understand the basic of the computer graphics and its hardware. The important questions on this topic are: they explain the operation of three-dimensional display system with vibrating mirror and all those things you need to explain. The architecture of the raster system with a frame buffer. Only it is been asked with a frame buffer, or else it can be asked with a some display coprocessor also. And explain the basic video controller refresh operation with the block diagram. And explain the architecture of raster graphics system with a display processor. So these are the important questions for on this topic. For this material, you refer the textbook chapter 2 with subsections 2.2 and 2.3, page number from 46 to 55. If you feel any difficulty with this topic, with this lecture, you are free to ask me at any time. Thank you.